Now, one place where negative exponents pop up is scientific notation, which is really useful when you're trying to express very, very large numbers or very, very small numbers. I have written out in the notes some instructions for scientific notation, but I think it'll be easiest for me to just explain this using an example. So in scientific notation, you always have a number that's basically between 1 and 10, smaller than 10 though, times a power of 10. And it turns out if you want to multiply by 10 to a positive power, if the exponent is positive, to do that multiplication, you can actually move the decimal, in example A, 5 places to the right. So 4.72 times 10 to the 5th, to write this in standard form, I would take that decimal, move it 1, 2, 3, 4, 5 places to the right. I'm going to have to put some zeros in there, and I end up getting the number 472,000. So 4.72 times 10 to the 5th is the same thing as 472,000. Positive exponents mean we're talking about big numbers. Rather than memorizing left and right, I remember positive exponents give us big numbers, whereas negative exponents give us small numbers. We're actually going to move the decimal to the left. That's because with a negative exponent, we're multiplying by a fraction, or technically we're dividing. So in example B, I've got 3.1 times 10 to the negative 2. So now I'm going to take the decimal, I'm going to move it 2 places to the left. I have to put a 0 in there, and I get 0.031. It's the exact same thing as 3.1 times 10 to the negative 2. So negative exponents give me small numbers. One more example, in example C, 6.05 times 10 to the negative 5. I'm going to have to move that decimal 5 places to the left. So 1, 2, 3, 4, 5. Again, negative exponents mean small numbers. And so my final answer would be 0.0000605, a very tiny number there. Now, if we want to take a number that's in standard form and we want to write it in scientific notation, once again, I like to remember that a big number is going to have a positive exponent. A small number is going to have a negative exponent. Now, to put a number in scientific notation, you want one non-zero digit in front of the decimal, or to the left of the decimal. So I'm going to move the decimal 1, 2, 3, 4 places so that there's just one digit in front of the decimal. That gives me 4.5. And then because I had to move the decimal 4 places, it would be 4.5 times 10 to the 4th. In example B, we've got a small number, so we're going to have a negative exponent. I move the decimal 1, 2, 3 places so that I have one non-zero digit in front of the decimal. Because I moved the decimal 3 places, my exponent is going to be negative 3. So 3.5 times 10 to the negative 3. Last one, 15.7. This time I only have to move the decimal 1 place. So now I get 1.57 times 10 to the, it's a big number, so positive exponent. So scientific notation is incredibly useful if you have a very, very large number and you don't want to write it out. It's also useful when you're trying to perform operations, specifically multiply or divide, and you have these numbers in scientific notation. So in example A, 2 times 10 to the 7th times 3 times 10 to the negative 5th, I don't really want to write this out in standard form and then do the multiplication, because I'll have a lot of zeros to keep track of. Instead, I'm going to use the fact that we are actually multiplying 4 things together, 4 numbers together. And when we multiply, we can do that in any order we want. I can do the 2 and the 3, and then I can do the powers of 10. 2 times 3 is 6, and if you want to multiply something with exponents, you add the exponents. 10 to the 7 times 10 to the negative 5 is 10 to the 2. That's my answer in scientific notation. If I wanted to write this answer in standard form, I've got a 6. I have to move the decimal 2 places to the right. So in standard form, my answer is 600. Let's do the exact same thing in example B. 8 times 4 is 32. And then 10 to the negative 7 times 10 to the negative 2, I add the exponents, I get 10 to the negative 9. Now this number is technically not in scientific notation because the 32 is a little bit too large. So there's a couple ways you can deal with this. In this particular problem, they want us to write this problem in both standard form and in scientific notation. So we've got the 32. In standard form, I'd have to move the decimal 9 places to the left. So I'm going to have to put in a lot of zeros there. In fact, I've got 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then the 3, 2. So that's my number in standard form. To put this number in scientific notation, I would actually take that decimal and move it back so the decimal is just behind the 3. Notice to do that, I actually have to move the decimal 8 places. So in scientific notation, this is 3.2 times 10 to the negative 8. Now in this problem, we were asked to put the problem in standard form, so we might as well do that first, and then put it in scientific notation. But you could also notice, to get this in scientific notation, if you look at the 32, you have to move the decimal 1 place to the left, and so that means I have to add 1 to the exponent. This process works with division as well. I have 8 times 10 to the negative 3 divided by 2 times 10 to the 4th. I can divide the 8 by 2, that gives me 4, and then to divide those powers of 10, I have to subtract the exponents. Negative 3 minus 4 is negative 7, so I've got 10 to the negative 7. That's my answer in scientific notation. To put it in standard form, I'd move that decimal 7 places to the left. That gives me something with 6 zeros and a 4. And there's my answer in standard form. All right, one more example. Let's take 3 times 10 to the 11th and divide that by 6 times 10 to the 5th. So I'm going to use the same process, but let's see, 3 divided by 6 is actually a half. And I'm going to write that as 0.5. That'll help me with the scientific notation. So 3 divided by 6 is 0.5. And then to deal with the powers of 10, I subtract the exponents. 11 minus 5 is 6. So I get times 10 to the 6. Now, just like in example B, this is technically not in scientific notation because I need to have a non-zero digit in front of the decimal. So what I'm going to do is take this number and put it in standard form, and then I'll put it in scientific notation. So we've got the 0.5 times 10 to the 6. That means I have to move the decimal 6 places to the right. And so in standard form, I get 500,000. To put this number back into scientific notation, I would move that decimal so that just the 5 is to the left of the decimal. That means I have to move it 1, 2, 3, 4, 5 places to the left. And so in scientific notation, this answer is 5 times 10 to the 5th. Now, once again, we had to write that answer in standard form, so we might as well do that and then go back to scientific notation. But notice in this case, to put it in scientific notation, you have to move the decimal 1 place to the right, and so that means you actually have to subtract 1 from your exponent. All right, that's it for this lesson. I know there was a lot of material in this lesson, so please come to office hours, use the tutors, or shoot me an email if you find any of this material confusing.